All right, so we are going to be getting into this guy, Isaac Newton's 3 laws of motion. So just to give you a little information about Isaac Newton, he did a lot of stuff before the age of 23. So a lot of these things that you see here are things that he figured out before the age of 23. So he predicted motions of objects on Earth and objects in space and put math to them to explain, like with numbers, how these things actually work so we can make predictions about the motion of objects. He came up with a basic formula that explains gravity and makes predictions about gravity. He discovered the shape of the Earth and proved it with math. It's an oblate spheroid. He also figured out a lot of stuff with optics. So like how a prism can produce a rainbow, or how bending glass can create magnification. He also invented calculus, and he used the calculus in order to just explain his physics. So before he was 23, he came up with these 3 laws of motion and explained them with calculus. So Physics 101 in college is actually what we're going to be learning, just like a bit more watered down. But he also came up with Calculus 101 and Calculus 102, which are 2 courses in college that students struggle with. A lot of students struggle with and need a lot of help with. And he was their age, and he discovered that kind of math and like proved that kind of math. So this guy was just an absolute beast. So the first law of motion from Newton is as it looks. So an object at rest will remain at rest unless acted upon by an unbalanced force. And also, an object in motion will remain in motion at that same speed and in that same direction unless acted on by an unbalanced force. So what this really means is if an object is sitting still and there's no forces being added or removed from it, it will remain still. And if an object is moving and there are no forces that are acting on it, it will continue to move in that direction forever, unless something else comes into contact with it or interacts with it. So that would be another force, an unbalanced force. So you may be thinking to yourself, this doesn't make sense. If I roll a ball on the floor and it just rolls, eventually it'll stop, even if it doesn't come into contact with anything. But you've got to remember, it has gravity acting on it. When that ball rolls over a surface, there's some friction between the ball and the floor, and we know that friction is the resistant force, so it slows it down. And also you can take into account air resistance as well. So if you were in outer space where there's very, very little amount of gas, so we would call it a vacuum, so there's really like no gas, but there's some technically. If you were in outer space and there was no planets around you and you just threw a ball, that ball would continue to go straight in that direction at that speed forever, or until it came into contact with something else. That's what Newton's laws, or first law, is describing, okay? So, this is an example of Newton's first law. An object in motion remains in motion unless acted on by an outside force, or by an unbalanced force. So in this image, you can see the bike and the guy are cruising along in the beginning, and then the bike is acted upon by the force of the wall being in its way. Now the bike stops, but since the guy doesn't come into contact with the wall, he keeps moving until he hits the ground and slows down, because an object in motion remains in motion. So he remains in motion until he gets acted on by an unbalanced force. So here's another example. As the car crashes into the wall, this guy keeps moving forward until he is acted on by an outside force. So that's the general idea. You're going to keep moving and moving and moving until something stops you, okay? That's Newton's first law. So I'm going to show you this video, and we're not going to do this lab because you guys are at home, but this all has to do with inertia. So inertia is directly related to an object's mass. The heavier something is, the harder it is to move. That's what inertia is. So inertia describes an object's tendency to resist change in motion, all right? So this would be like the difference between moving a giant rock or moving a small ball, right? You don't need as much force to move that small ball because it has less inertia than the giant rock, okay? So simply put, the more mass an object has, the more inertia it has. But mass is just describing how much the object weighs. Inertia describes how difficult it is to stop the object or to slow down the object, right? So a car has a lot of inertia, right? It's hard to, if you put a car in neutral and you push it, it's hard to get it moving because it resists motion. But at the same time, if a car is moving, it's hard to stop that car, right? You wouldn't want to stop that car with your body or with your hands because that object, that car, resists it resists slowing down, just like how it resists speeding up when you try and push it. So if an object is hard to get moving, that means it's going to be difficult to slow down. And that's what inertia describes. So we also talk about weight versus mass. So we've talked about mass being similar to inertia, but I also want to talk about weight. So weight is not mass, all right? So mass is going to be, let's say I'm 180 pounds. That's my mass, even though we don't use pounds to describe mass. Pounds is a description of weight. But let's say I'm 180 pounds on Earth, right? If I go up to the moon, my mass would still be 180 pounds because I'm still Mr. Schweizer. I still exist. It's still my body. But my weight, or the force of my body downward on the ground, is less. It's actually 1/6 of the amount. So on Earth, if I get a scale and I put it on the ground and I step up on it, it would say 180 pounds. If I took that same scale and I brought it up to the moon, where my weight is 1/6, I would stand on that weight or that scale and I'd be only 30 pounds because I'm 1/6 of my weight that I was on the Earth. But your mass is always the same because it's just as difficult to push me sideways on Earth as it is to push me sideways on the moon. And that's because my inertia is the same, because my mass is the same. I'm still the same person. So that's the difference between mass and weight. Mass is the amount of stuff that's in something, and that doesn't change whether I'm here or on the moon. But my weight is the amount of force pressed downward on an object, which is why if you could stand on Jupiter, your weight would be like, I don't even know, probably like 100 times more, okay? So that's the general idea. Sorry about the... It was good timing, actually.